Okay, so here we've got a question where oxygen is said to react with CH4, so that's methane, and that produces CO2 and H2O. And the question states that the CH4 is in excess, right? Which from that we can understand that the limiting reagent in this particular reaction is going to be the oxygen, right? And because we know that the oxygen is the limiting reagent, we know that in effect, well, if we look further in the question, what we've been asked to do is calculate the volume occupied by the CO2. What we can effectively infer is that the actual amount of substance of CO2 that will be produced will be primarily constrained by the amount of substance of the oxygen, right? And we have been given the mass of the oxygen. So, and in this question overall, we're trying to work out the volume, right? But in order to get to that, we're going to need to first try and work out the amount of substance of CO2 that was produced, right? So how am I going to go about doing that? Well, what I'm going to start off with is referring to the equation that links the moles, the mass, and the molar mass, right? So, and that's going to be that the mass is equal to the molar mass mR multiplied by the number of moles n, right? And in this particular case, we have been given the mass, right, of oxygen. So just for clarity, what I'm looking at is I'm trying to figure out, well, what's the number of moles of the oxygen, right? We have the mass, right? It's given in the question. The molar mass we can work out using the periodic table, and let's try and rearrange this to make the number of moles the subject, right? So if we divide both sides by mR here, right? So divide both sides by mR, we're effectively going to get that the moles, so the number of moles, and in this case we're referring specifically to the oxygen, right? So we can say the number of moles of oxygen is equal to the mass of oxygen divided by the molar mass of oxygen, right? Okay, so, and as I said, we've got the mass here. What we don't have is the molar mass, so we can use the periodic table now to work that out, the mass, the molar mass, right? So for oxygen, that's O2, so mR of O2, right? That's going to effectively be, so for oxygen, we can, as you can see, 16 is the relative atomic mass, and we've got two of them, right? So it's going to be 16 times 2, and that's going to be 32, right? And because it's molar mass, our units are going to be in grams per mole. Okay, so we've got that value now, 32. What can we do with that? Well, we're effectively going to plug that in. So the moles of O2 is equal to so the mass is given in question as I mentioned. So it's going to be equal to effectively 31.98 divided by the molar mass, right? So that's going to be the 32 we just worked out, right? And so I would invite you to have a go at working that out to see what value you get. If you do have a go, you should find that you get 0.999375, and that's going to be in moles. Okay, so that's going to be in moles. Okay, so that's the number of moles of oxygen, right? So number of moles of oxygen is equal to this, right? So but here's the thing. When we look at the question, as I mentioned, our goal that we're actually angling towards is figuring out the amount of substance for the carbon dioxide, and we can use the balanced equation to try and figure out, well, what's that as a ratio? How does it compare to the amount of substance of the oxygen? So if I set up a ratio here, so the number of moles of oxygen compared this ratio to the number of moles of CO2, right? What we can actually deduce is that, well, for every 2 moles of oxygen, as you can see, the coefficient here is 2. For every 2 moles of oxygen, we're going to have 1 mole of carbon dioxide, right? So that's going to be 2 to 1, right? And realistically, I want to try and get this to be a 1. So, and I can do that by dividing it by 2. But what I do to one side, I need to do to the other, right? So if I divide both sides by 2, what we get is that for every 1, so this is going to be a 1, and this is going to be half, so it's like 0.5 basically. So for every 1 mole of oxygen, we're going to get 0.5 moles of carbon dioxide, right? And therefore we can say that, therefore the number of moles of CO2 is equal to half multiplied by the number of moles of oxygen, basically, right? And well, we've got the number of moles of oxygen, right? So we have that here. So that's, therefore we can say that this is actually equal to half, or in other words 0.5 multiplied by 0.999375, okay? And if you have a go at working that out, you should find that you get 0.4996875, and that's going to be in moles, right? Right. Okay, so when we look at in terms of well, we've achieved the initial goal, right? So we're trying to work out what's the number of moles of the carbon dioxide produced, and we've been able to work that out here, but that's not what we've been asked as in terms of what we need to actually work out ultimately. Ultimately, what we've been asked to do is to work out the volume occupied at room temperature and pressure by the carbon dioxide produced in this reaction. And we've also been told in the question that 1 mole of any gas occupies a volume of 24 decimeters cubed at room temperature and pressure. Now, what is the implication here? Well, for every 1 mole of carbon dioxide, it's going to occupy 24 decimeters cubed. Therefore, in order to work out how much is going to be occupied by this specific amount of carbon dioxide, we need to multiply this by 24. So we're going to say, therefore, the volume of carbon dioxide, so CO2, is equal to 24 multiplied by, and then basically multiplying it by this number, right? So 0.4996875, right? So, you know, I would invite you to have a go, work that out, and see what value you get, right? And you should find that you get 11.9925, right? And in terms of units, that's going to be in decimeters cubed, okay? Now, the question, if we really refer carefully to the question, it does actually specify that our answer needs to be given to a maximum of 2 decimal places, right? So in this case, our answer we've got so far is to 4 decimal places. So we do need to do some rounding to actually get to our final answer. right? So we can say that therefore that is actually equal to, and if we round this, it's just a 2, right? We've got the 2 as the value after the first 2 decimal places, so this is simply going to be rounded down to 11.99, right? So it's going to be 11.99, and then that's going to be in decimeters cubed. You can say that's the 2 decimal places. All right.